postdoc of neuroscience at University of Geneva. Her interest lies in the neuroscience of language and how multilingualism shapes the mind and brain. And she's going to be presenting some really cool work from the Aptitude project today with a couple of new data sets which test hypotheses about core cognitive and linguistic functions, their association with those functions, and how they vary based on individual factors in a diverse sample of multilinguals. So the floor is yours, Irene. For it.
Thank you so much, and there's such a nice introduction. I sound very serious when you describe me like that. So I'm gonna try to share my screen. Do you see? Let me see. Do you see my slide? So yes, no.
Yes.
Okay, and do you see them in the proper view or presenter mode?
Proper view.
Yes, okay. Thank you. Be patient with me. I never use Teams, so I'm a bit of a newbie. Okay. So let's start. Thank you again for an introduction, Anders, and thank you for inviting me. This is very, very nice. This summer, I had the chance to meet some of you in Tromsø and had some nice exchangings about our shared interests. So today, I'm very excited to show you a little bit of what we've been doing in the last 5 years within the project Aptitude, as Anders mentioned. I don't know what's normally the policy. I'm happy to get questions, especially clarification questions, but questions throughout. So I'm happy if you decide to ask questions during the talk. And I don't see you, but just say something. Okay, so today the title of the talk is The Power of Studying Individual Differences, Insight from Dyslexia, Multilingualism, and Polyglotism. This is a bit of my background. I'm a psychologist and neuropsychologist by training, and today the work I'm going to show you has mainly been done during my PhD at the University of Fribourg, but yes, partially based in Geneva, and during my postdoc here at the University of Geneva, with the support and association of all of these institutions. Particularly under the umbrella of the NCCR Evolving Language, which is a National Centers of Competence in Research. It's a multidisciplinary, multi-centers research effort that has been going on for 5 years, which aims at becoming an independent research center exploring the past, the present, the future of language. So it's a big endeavor, and this is the umbrella under which our project was born and is developing still now. So this is a bit what we're going to do today. I planned, as per usual, when it comes to my stuff, a pretty packed set of things I wanted to discuss with you. We should be able to do it in time. I'm going to try not to be too boring or too details about all of these projects, but I will give you a brief introduction of why individual differences and how did we approach this in the Aptitude project. 3 publications that are related to the project that are already out there. One project on the polyglots brain, which is in preparation, which is quite new, and I would like to see what you think about it and your opinion, because the results are, as usual, never looking as you expected, and then some conclusions. So let's dive in and start from the introduction. In case I have to convince you, which it will be completely fair, why do we focus on individual differences and why are they so important for us? Well, we know that in general, in neuroscientific research and in the field of language too, there's a predominance of group type of analysis. So pooling together all of your participants and try to work with this middle part of the distribution, right? But variability exists. Our research and our theory should account for variability and try to explain why it exists and also leverage it to understand more about the functions we study. It is more realistic, is more ecologically valid, but of course is much more complex in terms of statistical analysis, but also in terms of interpretation. And you'd see with 2 of the empirical projects I'll show you later, there's a lot more unpacking. It's not always a given that the patterns you find are going to be easily explainable because there's much more exploration, a bit less hypothesis-driven analysis. Also requires a big sample, because if we want to sample individual differences, use them and have enough in our samples, it requires bigger samples that are not always easy to get, to collect in terms of fundings, in terms of time, in terms of staff. But the efforts of sharing data, creating consortia to pull the data together are bringing us there and making it easier for all of us to do this. The individual differences approach, so this idea of really sampling and using individual differences, is a tool for understanding the structure of language as a faculty. And I'm going to show you a very simplified example of how we can imagine this. So if we sample and analyze individual differences, we can explore patterns of association and dissociation between, for example, linguistic subsystem, linguistic and cognitive tasks that are relevant for language. And we do this by sampling as much variability as possible. The image above is just a possible example of the domains we might be interested in. You can represent it in a million different ways. And basically, this can reveal the properties of the underlying architecture of the language system. So what's left once we pull together, we have all of our participants and all that variability, what is present, what are the associations that are there despite these differences and resist to this variability, or what changes. On top of that, I work for the NCCR Evolving Language, so I'm interested in evolution too, and it has been suggested that individual differences are a driver of the language evolution, the evolution of language. And there's a paper from 2024, Jocelyn is the group at the MPI in Nijmegen, that shows that individual variability within a population does drive language change to facilitate communication, also sometimes at the expense of convergence. But the point being that variability within a sample, the presence of different profile between speakers in a population does drive the type of language we end up using. So it's, in my opinion, worth exploring even more. So how did we do it in the Aptitude project? How did we approach this admittedly very broad and very complex question that, you know, if you don't operationalize in a clear way, could bring you a bit everywhere? Well, we decided to sample variability as much as possible, first with our participants. So we sampled along a pretty broad continuum of multilingualism that I'm going to show you because I know a lot of you might like it. So from monolinguals, not many, we're based in Switzerland, to people that are very multilingual, polyglots and hyperpolyglots with a knowledge of a lot of languages. But also we sampled along the reading continuum, reading abilities and predisposition, including both dyslexic readers and non-dyslexic readers. In terms of the sample, it kind of looks like this. So these are actually the participants to the study that were involved in one of the bigger analyses. Each bar is a participant, okay? And the bar for each participant is composed by a little rectangle for each of their languages stacked on top of each other. The bigger the rectangle, the higher the proficiency, with 10 being self-reported full proficiency in that language. And it looks a bit like this. Pink is for dyslexic readers, which you can see, of course, they're a bit less multilingual, but still, especially in the context of Switzerland and Geneva, present a nice degree of multilingual experience. So this is a bit how it looks, and also this represents visually our approach in our lab, in the group, our approach to multilingualism. So we treat multilingualism most of the time, except you'll see in the last project, because I was trying to reproduce some other analysis, we did some grouping, but most of the time we represent multilingualism as a continuum. And we have 1 scores for speaking, for comprehension, for reading and exposure. That is a continuous measure, basically quantifying their proficiency in each of the amount of languages they speak weighted for proficiency. And I know you might want to discuss this more. I have a few more slides in case. But yeah, this is our approach, continuous approach to multilingualism. The other way in which we sampled variability and try to really kind of phenotype our participants is through measures. So we're interested in the group, in the 2 groups that have been taking part in the project, and you'll see some of the faces later. We're interested in language aptitude, which have been traditionally described as the cognitive abilities that predict language learning ability. So it's kind of a predictor, how well you can learn and do language learning and language in general. We broadened a little bit the spectrum of elements that we think are important for language learning. And in our ideas, it looks a bit like this. So language-specific skills are important, as well as cognition, language experience, perceptual and motor skills, arithmetic too. We sample brain structure and function, so the predisposition that can be given by brain structure and function, but also it's shaped by your experience too. And you'll see later, we added a touch of genetics to the mix. Before I dive in publications and data, I just wanted to show you the faces between this project. So the PIs are Nali Golestani and Rafael Bertele, which a lot of you know very well. Particularly, I guess Rafael has been around quite a bit. And the team that has been making this possible, was a huge data collection effort. I know you guys are familiar with this type of effort. So I always like to say it takes a village. And these are the villagers. And it wouldn't have been possible without a big group. Okay. So this is how the Aptitude project ended up looking like with all of those variability sampling I mentioned before. In the Aptitude project, we sampled 150 participants behaviorally and with brain and behavioral data, 152 with behavior. 2 people were claustrophobic, they discovered. Sampling from monolinguals to hyperpolyglots, so people speaking a lot of languages, more than 10, for example. 29 dyslexic readers included in the sample. And for all of them, we collected data behaviorally in terms of questionnaires, so their multilingual experience, so an extensive questionnaire on the languages they knew, how they learned it, their proficiency, age of acquisition, so on and so forth. Motivation for language learning, musical experience and training, reading history, and internal reasoning questionnaire. And then we had a set of tasks, there were many, and we programmed them all, that were taken mostly off the shelf, so they're tasks that are published and are out there, and they sampled cognition in an extensive manner with a particular attention to memory in all of its facets. Language-specific skills, so both skills that are important for language aptitude, so learning foreign sounds, foreign grammar, rote learning for new words, but also more literacy and literacy mediator skills that are important for learning to read and predicting reading ability. Fine motor skills, arithmetical ability, and musicality, so rhythm and tone perception. Then our participants were incredibly patient and spent 3 hours in the scanner with breaks. We passed the ethical approval. And we took measures of the structural MRI, so the morphology, structure in the brain and connectivity, plus functional measures like resting state and 3 localizer, 1 for visual perception, particularly the ventroccipital temporal cortex, to find the areas for words, false fonts, houses, faces, checkers, pretty classical paradigm that was shared with us from the group in Paris, from Dehan. A language localizer, that is the localizer used at MIT by the EVLab using AliceLock, so stories, listening to speech in first and second language, both intact speech and the graded speech as a control. We'll discuss more later how we use it. And then a music localizer with a similar principle with them listening to speech. So pretty passive paradigm. On top of that, as promised, as mentioned, we collected genetic data. And there's a series of genetic projects going on in collaboration with the MPI and Nijmegen. Okay, so what did we do with this data now that I gave you all of this preamble? The first thing we did, well, not in temporal line, but the first thing I want to talk about is the publication of the data set. We published a good chunk of the data in a publication called Nebula 101. Nebula looks like this. So 101 participants from monolinguals to multilinguals. It doesn't include dyslexic readers at the more multilingual hyperpolyglot group, because we have still some questions we would like to ask before opening this data up. A vast majority of the behavioral tasks, as you can see here, and the dimension we measured, plus structural measures in a structural MRI and functional measure for resting state and the language localizer in first and second language. So these data are out there. There's a publication that describes in depth and thoroughly the tasks, the participants, their background, and the data can be downloaded by OpenEuro. So if you're interested in questions that can be answered with this type of data, but still sampling a pretty variable set of participants, this is for you to use. And if you have any question, any doubt, or you want to discuss any possibility with this data, feel free to reach out. We're always happy to chat about this. Okay, So now I'm going to show you some of the data and what we did with them, because we have a lot of measures. There's a lot going on. I mentioned this is an exploratory approach to understand better what are the dimensions of language and language aptitude. So we started with what we called a behavioral exploration. And to do this, we use graph analysis, and we published this last year in spring, I think. So there's a lengthy publication that you can go and check, but I'm just going to give you just a gist today. To do this, we had, a multivariate behavioral data set. We wanted to grasp what was the relationship between individual scores and individual tasks, but at the same time, we needed to find some ways to the complexity and some at least clustering, some simplicity. So the best method we could think of, and we think it kind of satisfied this need, is exploratory graph analysis, which is exactly a combination of network analysis that modulates the single relationship between the scores, in our case, and factor identification. So still gives you some factors that, if they include a set of tasks that are interpretable, can also give you an interpretable structure. A little disclaimer, this analysis in this paper and the next one both work in a bit of an unusual way. So first, we ran the analysis on the whole sample, including all of our participants, including the dyslexic readers. And then we ran the same analysis, removing the dyslexic readers. Because we, yes, want to explore variability, but at the same time, we wanted to see what could have been the influence of the dyslexic readers, which in this case are really people with a dyslexia diagnosis, not just assessed in reading during the experiment. We couldn't run the analysis only on the dyslexic readers because, as we've mentioned before, you need a big sample for this type of analysis, and 29 is not enough. So the idea is that we ran the analysis in both subsamples, so everybody, and then only typical readers, and we comment and we explore what stays the same between the two, well, the sample and the subsample, and what changes. And I hope it's going to become more intuitive once you see it. But so we ran this exploratory graph analysis with all of our behavioral measures, and the results look a bit like this. This is what happens in the whole sample. There's a lot going on. I hope you trust me a little bit. I'm going to guide you through the result. So what you can see here is that we get one big cluster that has most of the tasks for language and cognition, so memory task, language aptitude task. Then we get a second cluster in yellow that is for music. So music, both musical experience and the scores in music ability. A cluster in green that contains tasks for literacy, so reading words and text, but also mediators, so phonological awareness abilities. And a cluster in light blue that includes multilingualism scores, so the continuous scores I mentioned before for speaking and comprehension and current exposure, plus the scores from the questionnaire on motivation and language learning. The last cluster, it's a bit of a trickier one, contains 2 scores for code switching, so voluntary and involuntary code switching that we added to the language questionnaires. These scores are never behaving as they should, so I'm happy to know what you think about this type of measurement and what are your solutions in case. But so what happens when we run the same analysis and we remove the dyslexic readers from the sample and we only look at typical readers? This happens. So at a first glance, what you can already see is that there's more clusters, which could indicate that there's more dissociable cluster, more automatized specialized systems when only typical readers in the sample as a signature of a more coherent and specialized language system, right? But there's also a lot of similarities. So we have clusters that contain together language and cognition. We have an isolated cluster for music that is exactly the same. Literacy is isolated also for typical readers, but it looks a bit different. So there's only purely literacy tasks, so reading words and text and pseudo words, not mediators. Probably indicating that when the dyslexic readers are in the sample, mediators and literacy correlate more because dyslexic reader needs still phonological support when they do reading, which is not necessary anymore for typical readers because it's more automatized. Multilingualism also looks a bit different in the sense that when only typical readers are in the sample, multilingualism and motivation for language learning separates, so they are dissociable. So what did we learn? A lot of stuff. First, there's a stable association between language and cognition, at least at this level of analysis. There's isolation of multilingual experience, even though between the two samples, there's a bit of a difference with the relationship with motivation, but multilingual experience separates from the tasks that should test language aptitude. There's isolation of musicality, which was a bit of a surprise for us, but it's pretty stable across different level of regularization in the two samples. There's isolation of literacy, even if we have a differences between sample, which could be sign of their automatization and specialization in typical readers. And the overall bigger difference is that between the two samples, we have more specialized clusters for typical readers only. So this is kind of what we learned from this first exploratory pass, only to looking at the behavioral variables. I don't know if there's any question at this point. I already threw a lot at you in 20 minutes. But in case, let me know. So if you don't have any question, we're going to move on and add another layer to this and add brain data. We wanted to understand and unpack the relation between all of these behavioral variables and associate them with neural metrics that we think are relevant for speech processing in L1. And from this, everything I want to discuss, you can find in this publication that came out this summer. And is openly available. And here what we did is, again, we took all of the behavioral measures and we took activation for L1 in speech. So start listening in L1 because L1, well, it's, for example, in a multilingual sample, first, more homogeneous. So we didn't have to worry about controlling for age of acquisition or proficiency in L2. And we also know it's an important signature. Abilities in L1 are predictor of language learning, and abilities in L1 is particularly in speech, and activation in speech and, how do you say, overlap between activation for speech and reading is a predictor for good reading. So we thought it was an interesting neural signature to start with. But now the challenge is we have a multivariate behavioral data set. We have brain data, which we know are pretty complex, a lot of dimensionality. We have two data sets, two different modalities, different dimensionalities. How do we get out of this with the statistical measures we have available? Well, we decided to use what is called partial least square analysis, correlation. I don't need you to understand what's going on here. I'm just going to tell you one main message is PLS works very similar to principal component analysis or independent component analysis. So the idea is you extract components that explain the shared variance between variables. PLS does this between data that come from different modalities or different data types, so brain data and behavioral data. So it's able to do this in data sets that are different also in dimensions. So basically, you create a correlation matrix between the two. You extract components, and exactly as in PCA, you can go back and see how each individual variable in the two data sets contributed to the component, and through that, you can interpret what that component is for. So this is what I was mentioning before when I was saying that this type of analysis requires a bit more interpretation. But I hope I'll convince you that there is something there, there's a structure there. So we ran this analysis again, first in the whole sample, and then only in typical readers. And we get this. I'm going to go in and explain in depth all of the components, but I'm just going to show you briefly here. When we run the analysis in the whole sample, we get one significant component that explains the association between brain activation for speech and all of our behavioral variables. And in the brain, it looks like this and explains 36% of the variance. When we run it in typical readers, nicely mirroring the behavioral analysis, we get three components. They explain 44, 19, and 8% of the variance respectively, and they look a bit different or a bit similar as it happened in the behavioral analysis. So we're going to go through them. Just as a disclaimer, in the papers, you find all of this explained in depth, but for the purpose of today and of time and of you not falling in a postprandial sleep, I'm going to skip this last component because it explains very little variance and it adds a bit of complexity to the story. And I think we can only focus on these. Okay, so let's start from the whole sample, as before. When we run this analysis, we get one component that it looks like this. So the way you can interpret this, again, it's like a PCA, it's like a component, and these are the association of each individual behavioral variable on the left, or the activation in each region of interest in the brain. We parcellated the brain activation using the Glasser Atlas to reduce a bit dimensionality and not go voxel-wise. And what you can see is that this first component is associated with better score in higher level. You have to trust me, or if you want to read all of the tasks, we can also do that. Higher level cognitive and linguistic skills, particularly for memory and grammar and phonological awareness. So better score there, associated to higher activation in areas of the language network known for being involved in combinatorial processes and semantics like the ATL and amodal semantic hubs like this one. So these are all the variables, so all the behavioral variables, the scores, and the activation there that are significantly associated with the component, blue indicating positive association, okay? So this high level component, it has memory, it has combinatorial process, grammar processes, a bit of phonological awareness that comes out in the whole sample. When we discuss this in typical readers, we run this analysis in typical readers, we said we get, oh, it's not changing the slide, we get more components and we have some similarities as well as some differences. So let's start from the first component that explains 44% of the variance. If you notice, it looks very similar to the first component of the whole sample. Very good. It's a sanity check. It would be surprising if it didn't. It's a subsample of the previous one. But it does look different in some sense because first thing you can see, there's more tasks associated with this component. And these tasks are mostly measures of phonological, well, I have a higher predominance of phonological abilities and reading. So there's more reading in this component. Also higher involvement at activation, so more regions that are related to this component in the auditory areas, secondary auditory areas. What does it mean? That when we only have typical readers, literacy abilities tend to associate more strongly with other language components and cognitive components, which is absolutely in line with what we know from the literature and the dyslexia research, because it's in line with the idea that is called the hypothesis called speech print convergence hypothesis. So this idea that good readers recruit similar networks for speech and print processing, and this overlap is a predictive of good, successful reading development. So, okay, this is the first component. Again, a very high level component, also in terms of the areas that are involved. The second component looks quite different. So first and foremost, you see some reddish, pinkish, which means negative relationship with the component. And on top of that, the areas that are involved in the task are observably different. So we'll unpack it slowly. The second component shows negative association, so poorer scores, negative contribution from tasks reflecting mostly automatization, motor speed, and lexical access. So we have tasks like the rapid automatized naming, finger tapping speed, whereas in the other component we had finger tapping dexterity. So here we're really talking just about speed. Reading of text, yes, but nonsensical text, so where you cannot do prediction. So we have poorer scores in this lexical access speed tasks associated with higher activation in auditory and sensory motor areas. So it seems like it's associated to lower level unimodal auditory and sensory motor cortices that are activated kind of as a compensatory mechanism for people that perform poorly in these tasks. So overall, what we can see from this patterns of results is that across the sample, we have, in both the samples, we have a main component that corresponds to a higher level language network known to support semantics and combinatorial processes, as well as grammar, mnemonic, and partly phonological skills. And when we exclude the dyslexic readers, we also have this relationship with literacy together with other speech-related language scores. We also have more components when we only look at typical readers. Again, probably as a product of less variability because we don't have the dyslexics in the mix, but probably a specialization and more automatized processes. And what we learn about the language architecture that I mentioned before is that in typical readers, it is suggested that there's an existence of a higher level component that includes the activation in associative amodal areas, and a lower level, maybe compensatory component, including sensory motor, unimodal areas, and its link to automatization. So this seems to be really this split. Okay. So this is it for the analysis that we've done in an exploratory manner on the whole sample, really exploring individual differences. Now, if there's no question, I'm going to change gears a little. Because up until now, we treated multilingualism as one of the variables to model and to explore in our data-driven manner. In the next project, actually, multilingualism is going to become an independent variable of interest and also a grouping variable at some point. What we wanted to see, because our sample is so multilingual and we also have people that are very, very multilingual, you could classify them as polyglot, and the next slides will discuss what it means. We wanted to see how speech processing in the polyglot's brain and in the multilingual brain looked like. So I'll start with this, which is an incredibly annoying slide. I'm sorry, but it is a necessary premise. And it's a conversation that I know a lot of people here have all the time and that we think about all the time when we do research. But I think it's important to have a slide like that to let you know that I thought about this. What's a polyglot? Etymologically, polyglots means someone that speaks many languages. So more than one. It could be a trilingual, it could be anything. Nowadays, at least in the field of multilingualism, we think about a polyglot as someone different from a bilingual or multilingual speaker. And how do we decide that this person is different can be in two ways. One is a qualitative approach. So, for example, some people propose that polyglots are different because of some affective features that there is to their language experience. They seek language learning. They're motivated, they're independent, they are engaged. So this would define a polyglot, someone that we, in our group, we tend to call an elective polyglot, someone that goes and seeks experiences with languages and learning new languages. Another way you can define polyglots and hyperpolyglots is based on the amount of languages they know and how well they know them. So some people have proposed that 6+ languages could be a good threshold because it would go beyond community multilingualism in the sense that there's places in the world in which you need 4 or 5 languages to exist and do groceries, for example, if the community you live in is very multilingual. So 6 would be already a sign of you knowing more than what is necessary societally. Some people propose that hyperpolyglots are people that can speak 10+ languages. For example, Michael Herrera in his book Babel No More. Okay, but this opens a huge Pandora box, right? Because first, what is a language? Meaning, do we count dialects? Do we count languages that don't have a writing system like Swiss German? Speakers here in Switzerland speak Swiss German, but they learn standard German, high German. So do we count dialects? How do we count them? What is fluent? So when do we count a language? Do we put a cutoff of how proficient they have to be, how early they have to start? So these are all decisions we take every time we do a multilingualism project, even with bilinguals. Every time we decide to measure multilingualism and group multilingualism, I don't have a solution. I think in the field we're coming to some good practices. We all go about it a bit differently. This is all to say, I'm not fixing this today. I would love to discuss this with all of you and I've done it a bit with some of you. But in this project, for the sake of reproducing what has been done in previous literature with similar brain data and similar populations, we are going to talk about a polyglot, at least when we talk about grouping and don't treat multilingualism as a continuum, as someone that has a knowledge of at least 5 languages, an advanced proficiency in 2 of them, advanced proficiency being defined as a self-reported proficiency of 8 out of 10 at least in the modalities that we sample, so comprehension, speaking, and reading. This can be discussed. This is arbitrary, as every categorization like this is, but this was already out there in the literature, so we started from this to at least try to reproduce what was out there. So I talked about previous work, especially when it comes to the brain in polyglots. So there's a paper from 2024 from Ammons that showed post-mortem cytoarchitectonic analysis of the brain of one case, a polyglot, Emil Krebs, which revealed differences in Broca's region, BA45 and 44, in terms of the assembly and the connectivity, not the connectivity, but the assembly of the connectivity in the layers and of asymmetry. So suggesting and these differences were not found in the visual area. So suggesting that Broca's has something special in people that are they are polyglots and speak many languages. Other two works that have been published in 2021, 1 year after we started the project, and 2024, are using exactly the same localizer we use because they come from MIT, the EV lab, which is the same place that developed the localizer we use. In that case, they had a group of 17 polyglots, and what they found that then they reproduced and extended to 31 in the second paper. And in that work, they found that the activation within language region is smaller in magnitude and extent compared to controls for polyglots. So they argue that this is a signature of efficiency of a very trained language network, which is pretty cool. It's a pretty nice result. The way they define the activation for language processing in the two works is looking at the activation of sentence once you subtract the activation for pseudo word reading, or the activation for intact speech once you subtract the activation for degraded speech, which is done to conceptualize and to analyze the part of aspect that is higher level aspect of language. Higher level aspect of language, semantic and morphosyntactic aspect, because they're washing out, they're subtracting the activation for this more perceptual and lower level condition that don't have any syntax and meaning in it, right? They also focus on cortical region of interest that are for sure important for language, which are the one I plotted here more or less, because I think they use a slightly different mask, but it's very similar to this, or at least that's what they use in the lab now. And they focus on group comparison. So what they decided is, using the criteria I showed you before, they divided their participants in polyglots, so people speaking knowing 5 languages and speaking 2 at an advanced level, and a larger control group that was less multilingual. They're 2 very cool studies. They have a lot in common with ours because we also found some of their methods very useful. But we wanted to move a bit forward. We also have a different approach, as I've shown you, to the idea of multilingualism. So I'm going to show you what was the plan and what I was expecting for each of these analyses, and then I'm going to show you the data. And I would love to hear what you think. This is a bit of foreshadowing. So the analysis we planned was a group comparison for replicability. So we divided our sample based on the criteria in the 2 previous studies with polyglots, but also to use multilingualism as a continuous measure, as a regressor, not doing any grouping, with the idea that the continuous approach might yield more nuanced results and more statistical power to detect brain differences in activation during speech in our sample. This is particularly true because now we wanted to move. I told you they looked only at region of interest before, previous works. We wanted to move to the whole brain. So we also need more statistical power to detect an effect there, right? Why the whole brain? Well, first, language in general seems to systematically activate additional areas, as shown by a review from 2023 by Sabrina Turker, who's also a postdoc in our lab, at the time wasn't yet. They've done meta-analysis of almost 400 studies exploring language, and these are the areas that showed activation across all of these studies. There are the classical areas we came to expect with a left bias, right? STS, STG, IFG, but also there's quite some involvement of medial areas, subcortical areas, cerebellum, and visual areas that are important in the language network, like the visual word form areas. That, as we discussed before, we expect to be really integrated in good readers. So we were interested in knowing what was going on in the rest of the brain. Also because we're interested in multilingualism, right? And we expect multilingualism to affect areas for control, for switching, for possibly memory, right? To hold the representation and the use and the mechanism behind different languages, being language use and switching. Also, looking at the literature on cognitive reserve and the bilingual advantages, there's one that came out very recently in Nature Aging that I know a lot of you know, read and commented. The bilingual advantage, the findings in this field point to an extensive advantage that we would expect to go beyond just language itself and maybe be detected in areas that are beyond the areas that are relevant for computation of semantics and morphosyntax. So the idea was we're going to find other areas that have differences across the multilingualism continuum outside the core language areas, the semantic morphosyntactic cortical areas, possibly subcortical structure, medial frontal areas, reward regions, and we can discuss this more because this is of particular interest, and more, maybe also reading related areas. Last but not least, what we wanted to do with this analysis is explore single conditions. Because as I've told you, previous work focused on this type of contrast, so higher level aspect of language that are calculated by subtracting from the exposure to intact speech or full sentences at the graded condition or pseudo words reading. So to wash out the modalities and to wash out the activation that is not strictly relevant for morphosyntax and semantic. But we wanted to see what was going on in the single condition, particularly in the graded speech. Why? Because what we were expecting is that more multilingual participants might have higher activation in language areas during the graded speech listening. And this is coming from also the report of our participants that came out of the scanner and told us they were trying to understand what was in the snippets of the degraded speech during the MRI, which is not understandable as unintelligible speech. There's no way to understand it, but they were trying to. So they were probably engaging language areas, which has an impact on the activation you see once you do this operation. So you subtract this activation. You're probably washing away some language activation too in these people. So I wanted to see what was going on. Okay, so this is my plan. This is what I want to do, what we were interested in. Neat, we have ideas, and we have hypotheses. So it's gonna look like this. So first we compare two groups, categorized as I've shown you before, on the three conditions, so intact versus baseline, degraded versus baseline, and intact versus degraded, and see if there's any areas that are more active in the polyglots group than control or vice versa. And then we run into our continuous analysis using multilingualism as a continuous measure, and we treat them as one group. And again, we analyze all of the three conditions that we can get from our localizer. So I'm going to show you quickly an overview of the results when we have two groups. So most of the things are not significant. In comparing the groups, we never find higher activation for polyglots than control. And we find only one contrast in which control have higher activation than polyglots in the degraded condition. And now I'm going to show you how it looks. It looks like this. It's in the cruise 1 and 2 of the cerebellum. Again, during the graded condition, which would mean that in a control participant less multilingual group, have more activation in this area of the cerebellum that it has been associated to language processing and executive function and working memory. My interpretation ends here in the sense that it was a bit surprising. I didn't really have an expectation for this, but what brought me, like after this, what I decided to do is just go back to my sample, to our sample, and look how this categorization looks for us, right? So these are the participants. It's the plot you've seen before. There's no pink anymore because there's no dyslexics in this analysis, only typical readers. And it's the same as before. It's the participants, one little rectangle for each of their languages. The taller the rectangle, the more proficient they are in speaking in this case, okay? They look like this. So probably the grouping, what we expect from the grouping is it cuts somewhere probably here and divides this participant from polyglots to a larger control, which, I mean, the grouping is already something unnatural that I naturally don't embrace, but it should look like something like that. Well, it actually looks like this. So pink is control, and blue and green are polyglots and hyperpolyglots. And what happens, because the criteria, I'm going to remind you, was they need to know at least 5 languages and speak 2 at a high level, advanced proficiency, is that you have participants like this one who speaks 2 languages very well and has knowledge of 5, yes, but these 3 are very minimal. That ends up being a polyglot, whereas you have a participant like this one who knows, I think there are 9 languages. I counted it already 5 times and I keep on forgetting. But because it just knows one of them at the advanced level, according to the threshold, this person here is considered a control. So I honestly, I mean, I wasn't super in love with the idea of comparing groups. This gives me even more doubts about this categorization. So I was very happy to move on to treating multilingualism in a continuous manner. We could try to group them in different ways and different using different criteria, but then we would give up completely to replicate what has not been done previously. But if you have ideas of solution, I'm happy to hear them. Okay, so this is what happens when we use multilingualism as a continuous measure, as an independent measure. So we see that in all of the condition, more multilingual people show higher activation in some areas, whereas in only one condition, they show less activation in the degraded condition. And we're going to look at it and how it looks. But let's go back to the hypothesis and the plan work. Yes, one idea we confirmed. So the continuous approach gives us more statistical power to detect brain differences compared to the 2 groups approach, where much less was significant. Okay, at least this was reassuring. Let's see how it looks now. So if we look at the intact condition, so intact versus baseline speech, what we see is that multilinguals have higher activation in the areas here in blue. So the precuneus, the lingual gyrus, and quite some clusters in the right cerebellum. The precuneus is an area of the default mode network, but as I've mentioned before in the analysis with the PLS, the brain behavioral analysis, is also an area that is important for semantics, part of the emoto-semantic hubs. And the lingual gyrus has been associated with reading and orthographic processes. So it could be that more multilingual people either do more mind wandering during speech or more access to semantics in their semantic repertoire. Also, they might have more integration activation in more reading related areas. And these areas of the cerebellum have been associated with working memory, cognitive control. With the cerebellum, I mustn't have a bit of difficulties interpreting what's going on. So if you have ideas, let me know. So this is for the intact condition. Then when we look at the degraded condition, there's a lot going on. In blue, you see areas that are more active in more multilingual people, and in red, areas that are less active in people, or more active in less multilingual people. You can see it as you want. So one thing that I thought was very, very cool is that the areas in blue are the IFG, bilateral IFG, left middle temporal, and then we have the intracalcular in sulcus bilaterally, which could be linked to mental visualization. But IFG and middle temporal are areas that are usually related to language processing. And this is the degraded condition. So it seems that more multilingual participants tend to activate more traditionally language processing areas when they're hearing the degraded condition. So this is something we expected also from their report. And this is something that, as we mentioned, could impact then the contrast when we subtract this activation from the intact condition. Multilinguals also activate less the ACC and the parahippocampal areas and hippocampal areas with the right bias in the case of the hippocampus. This to me is a bit harder to explain. It could be that less multilingual participants have more activation for control during the degraded condition, but because it's not language, it's a bit of a harder find to explain. When it comes to intact versus degraded, so that's subtraction, keeping in mind all the caveats I mentioned, what we find is that more multilingual people have more right lateralized activity in the superior occipital areas bleeding into the angular. And the angular, we know, it's an important area for access to lexicon and has been shown to have differences in people that are multilingual, especially having languages that are more typologically distant. And the right hippocampus. So that maybe, so this contrast should represent higher level of language processing, morphosemantic and syntax, so maybe more multilingual people activate more the hippocampus in terms of as a mechanism to access a wider vocabulary and lexicon. So it looks like this. If we go back to all of our analysis planned and hypotheses, it's true that the continuous approach is more nuanced and gives us more power. The differences we found across this continuum are outside language core areas mostly, but not where we expected them. Like there's no subcortical. I want a little bit of caudate to happen, nothing like that. And there's higher activation in more multilingual participants during degraded speech listening, which could impact intact minus degraded as a condition. So we should keep that in mind when we interpret this data. So the categorical group comparison gave us fewer differences, and the continuous approach of multilingualism wasn't exactly what we expected in terms of resulting in more activations of some subcortical areas. More multilingual participants had greater activation outside the core language network for intelligible speech, and engaged language areas more for unintelligible speech, maybe as an attempt to comprehension. Okay, we are landing. So final conclusion to put all of these things together. What I would like to conclude is that individual differences provide a powerful lens for investigating the architecture of the language faculty. In typical readers, linguistic and language-related measures separate into smaller, more numerous clusters, indicating possibly greater specialization. And in typical readers, we also reveal that a complementarity of the structure of language abilities with a higher level modal component and a lower level unimodal component. Viewing multilingualism as a continuum offers a more accurate informative approach than categorical classification. And in multilinguals, differences in speech processing activation predominantly appear outside traditional cortical language regions. So this is my take-home message, and I thank you very much for your patience. I've talked quite a lot. I hope it was interesting, and I'm happy to hear any questions, doubts, or ideas. I do not hear you.